All right, so welcome everybody. This is going to be the last lesson for chapter 4, and this is about regression and median lines or median fit lines. This will be a desmos heavy lesson. If you have a graphing calculator at home, I can try to help you with that in class if you bring it in. But otherwise, this is going to be a lot with desmos. The main reason we're going to use that is because the technology that they have and the way that we can do this regression and the line of fit is actually pretty remarkable. So what we're going to do first, though, is start the bell work as always. And so if you guys could pause the video and answer these questions, it should not take you 5 minutes to do it. It should take you a lot less time. All right, so starting off, the scatter plot on the right shows the number of guitars and number of amplifiers. Does the situation illustrate a correlation only or a correlation and a causation? Well, if you guys look at this, we're just looking at the number of guitars and number of amplifiers. And I don't see a 1-to-1 ratio. So in actuality, this, ladies and gentlemen, is just a correlation only, okay? Correlation only because nothing here on this table is going to tell you exactly what helps with anything else. Okay, it just so happens that, I mean, if I saw a 1-to-1 ratio, then I might think it could be that every time somebody bought a guitar, they bought an amp, but that's not the case. It looks like all the numbers are different each time. It wasn't necessarily 1-to-1, so that's the kind of situation you want to look at. Just use kind of, I guess you could say, common sense a little bit when you're looking at these. Number 2, which situation shows a correlation only, but not a causation? Okay, so for example, A, the amount of taxable income and amount of taxes owed. That, ladies and gentlemen, is a causation. The more money you make, the more taxes you pay. Monthly rainfall and the water level of a lake. Well, if you guys are fully aware of the drought conditions that have been up north in Arizona, we have a lack of rainfall, and so Lake Mead up north, the water level keeps going down, so that is not one. Hours of driving practice and score on a driving test. That's kind of, that could be a correlation only. And then but let me look at the last one real quick. Water usage and the amount of a water bill. Ladies and gentlemen, that is a strict causation. When my water bill in the summertime goes up because of my grass. And so in actuality, the answer here is C, when I water my grass at home. My summer bill is much more expensive than my winter bill. Which of the situation here shows a negative correlation and causation? So it's going to be negative, okay? And as if you look at this, number of boots sold, the number of sandals sold, that's actually a correlation, but that's not a causation. Numbers of employment and salary, if it's ever negative, ladies and gentlemen, get out of that job, please, immediately. And so I'm left with A or B, because technically speaking, you could have, if your profit's going down, then the value of your stock will go down. But actually what usually happens is the answer is B, just to let you know, because the hours you spend on your cell phone does take away your battery life. But many times from an analysis standpoint, for me, when I look at the financial markets a lot for one of my other classes, my financial algebra class. If a company's profit does not meet the expectations of stockholders, the value of the stock will actually go down, even though they've made a lot of money. It's kind of weird how that works, but some people have expectations, and if you don't meet those expectations, then the value of your stock goes down. So we're going to start modeling, and we're going to be using a lot of technology, okay? We are going to take basically everything that we're going to learn today, and we're going to put it in tables and create models. We've used lines of fit and scatter plots to evaluate trends. Now we're going to write equations using of best fit, using line regression, and write equations of median fit lines. So right off the bat on your notes, you guys will have your vocabulary. And I have my teacher's edition over here to the left. So you have your, please make sure you guys circle and underline the best line of fit, what a linear regression is, and then your correlation coefficient. And one key factor with the correlation coefficient is that the closer the correlation is, which means the stronger the dots are, and I'll show you that as we go along, the closer the number is going to be to 1 or -1. Okay, so that's very important that you guys understand. So when we go through, I'll show you where that's at. but it's very important that you guys understand that basically a correlation of 1 would be you have a line and you have a dot on every single, all of your dots are on the line itself. That's perfect, right? That'd be like writing a linear equation. If it's like 0.9, that means you'd have a line and all the dots would be right around it, like really jammed in, so you could see a line going through. So that's kind of what that correlation represents. Okay, so as we go through, make sure you guys pull at Desmos, because I'm going to show you the trick right now on how to do this. So best line of fit. Basically the rest of this lesson we're going to be going back and forth between Desmos and not. Find and interpret the correlation coefficient. Let x be the number of years since 2008. Okay, that's very key for you guys to understand. So on this chart here, this is going to be the x and this is the y. Okay, but it's from every year since 2008. So if that's the case, when I enter these coordinates in, what would be 2009 minus 2008? That would be 1. Okay, so my x value here is going to be 1, x value here is 2, 3, 4, and you guys get the drift, right? So instead of actually entering in these years, we're going to enter in the values of 1, 2, 3, 4, 5. So that way we know if we start at 2008, okay, the next year, 2009, the cost was $10, okay? So that's where we're starting. Now, I don't, we'll find out what the original is in a second here. So what you do is you go into Desmos, okay, and I'll put it on the left here, and then you click this little plus button and you add a table. And then what I like to do is kind of like we did in the last lesson, I'll go through and I'll enter all my values on for my x's first, especially if it's in sequential order like this. It makes it a lot easier. And then I'll go up and I'll add the y values. Now if you struggle with that and you want to go do your own thing, please feel free to do that, okay? And by that I mean go left to right. It's just sometimes it's easier if you go vertically straight up and down. And here are my values, okay? Now here's the key functionality that I need you guys to write down, okay? What you're going to do now is you're going to write an equation. Let me just do it on this keyboard real quick. You're going to write an equation. First, you're going to do it. You're going to click in and want a new expression at the top, and you're going to start typing it out. Now, open this keyboard up. Now, you can go back and forth because I have a home keyboard here, so I'm going to go back and forth between them both. And so it's going to be we're going to do y equals mx plus b. But it's going to be written a little different. So it's y, and then if you click on this ABC, you get a little drop down right here. It says A with a little b. If you click on that, you'll see the graph kind of drop, and you want to put a little 1 right here. Okay, and what this represents is that you're looking for every y to the 1 value on this table. See, y1, y1. We're matching it up. Then what I need you guys to do is click this little approximation button here, and then we're going to do mx because that's where we're going to next. And then we need to do the drop down again to get the little sub letter 1. And then you'd finish it off and look at that. Plus B. Okay, make sure everything is in order like this. And check it out. It makes a line of fit for you. Okay. And what this does is this is taking all the data points that you have. So all your y data points and all of your x data points. And it's creating the linear equation for you. In the past, okay, I've had you guys pick 2 points, and when you pick those 2 points, you would find the slope, and then you would put it into the slope intercept, or not the slope intercept, the slope point slope formula, and you would put in the point, you'd put in the slope, you know, the y equals m x minus x1 plus y1, and then you would simplify that. Guess what? It's all given here for you. The slope of this equation is 1.21 and my y-intercept is 8.25. So it says find and interpret the correlation coefficient. Okay, the correlation coefficient, ladies and gentlemen, is this r value. Okay, the r value right here. So my r equals 0.98. Is that close to 1? Yes. So it's a very strong correlation. And is it positive or negative? You're looking at the graph, it's positive. Okay, so what I want you guys to know, and I'm going to type this out, I think it'll go faster if I do this, is that we have a very, let me change the font on this. So it's going to be a strong, it's a strong positive correlation. Okay, that's kind of what you want to know. So find and interpret the coefficients, and then let X number be the amount of years, and that's what we're looking for. Now, if I wanted to write the equation, I could write the equation going off my data, right? So my equation for that line, because you see the parameters set here, make this a little bigger, is it would be, oops, I didn't do that. Undo. Oh, I need to escape. Okay, what my equation would be, y equals, and my m value is 1.21 x, and then it's plus, right? Because the plus value is 8.25. And there, ladies and gentlemen, is my equation. Simple as that. One thing as we delve deeper into this lesson, excuse me. One thing as we dive deeper into this lesson, I want to make sure you guys understand. Technically speaking, going forward, if I was giving you, if you guys remember from the previous lessons, I've asked you to find 2 points. And I've given you 2 points that you could look like this. And then, ladies and gentlemen, I said you need to do find the slope. And then once you find the slope, you would enter the slope and one of the points into the point slope formula. Then you would solve simply to get the y equals mx plus b. You don't have to do that anymore. Now, if you want to choose to go that route, please do. But as we get farther along the line into standardized testing, ladies and gentlemen, I will ask you to please use Desmos to solve all of these questions. I will ask you to put in the 2 points just like this. So if my 1 point was 110 and my other point was 210.50, heck, let's change that. What if it was 4 and 15? Then look what we got here. It's going to give me my slope automatically, and it's going to give you my b. Now I know from fraction wise this would be 1.67, but in a fraction standpoint that's actually 1 2/3, and then it would be the slope, and then the intercept is actually 8 1/3, because of repeating 3 like that is 1/3. So I know that by using the calculator in my own head and from knowing what a fraction looks like. You guys should be able to do the same thing or be close to that. Okay, so just going forward, and I'll show you more about this as we go along, that you guys can now use this system to simplify and to create equations simply, effectively, and very rapidly. Okay, all right, write an equation for the best fit line of each data. Find and interpret the correlation coefficient. Oh, by the way, that's one thing I forgot. The correlation coefficient is the R. So in this one here, the correlation would be R equals 0.98. Correct? I deleted the data, so I can't tell, but I believe that's what it was. So it's got a strong correlation. That's what I'm looking for from you guys, is to give me the R value. Okay. In our classroom, we have calculators that will help do this. But ladies and gentlemen, there is no easier way than Desmos. I'll tell you that much right now. All right, on your own, guys, put these data points in, and then go from, once you put these data points in, round to the nearest 10,000, let X be the number of years since 2007, okay? So knowing that, what do you think this first value is going to be? This first value right here is going to be the number 0, because it is 2007. Okay, so this is 0, this would be 1, 2, 3, so on and so forth. Ladies and gentlemen, I'm going to work on my own, so you can pause this video or look at your notes and make sure you guys fill out this bracket while I go through and plot these points. All right, so hopefully you guys are done. If not, please pause the video right now, and then we'll go from there. So if you guys are finished, if you put this in the desmos properly, you should have gotten this set up, okay? So what is my data points here? Show a positive correlation. Is it strong? Anything above a 0.5 technically is a strong correlation, and so it does have a strong positive correlation because my R value is R equals 0.61, so my R equals 0.61, so technically that is a strong, it's not strong, but it's a positive correlation. Correlation. Okay, and I'm going to run out of room because I don't think I can write off in here. Okay, so and then now the other value, now let me give you guys a little tip. If you guys did what I did and you put in a second table, all right, what you want to do is turn off the first one and turn the second one on. Now, the problem is that this first equation we wrote says the values of table 1, okay? But if you look at my second table, it's actually the values of table 2. So you need to make sure you change these numbers here to 2, and then change this number here to a 2. Change those, and there we go. Now I'm on the other one, and there are my green dots with that correlation right there. And now I have my correlation for the green. It actually looks like we have a stronger correlation. So if I were to compare between the two, it looks like the other team is more consistent, okay? That there's a stronger correlation because the correlation here is 0.849. I'd be 0.85 because it says round to the nearest 10 thousandths. So I believe that's 0.85. Actually, that's hundredths. So it would be not it would be thousandths. So that's hundredths. So we're looking at 84. It would be actually 5 because of the way it rounds up. So know that that's 1. And then what is if I want to write the equation, my equation would be y equals my m, which is 5.95 plus 50.1. 67. Sorry, I keep sneezing. All right, so hopefully you guys understand how to do that, okay? All right, let's move on. Real-world analysis. Graph and analyze the residual plot data, comparing the years since 2010 to the cost of repairs. And this would be like if you were having a car, okay? So we're just going to graph the analysis on this. I forgot to tell you what page we're on, guys, in your book. Hopefully you have it open. If not, we are on page 260. Okay, it's still the same thing. I want you guys to plot these out and see if you see any type of correlation. Okay, so go from there. You guys, I'll plot it out while you guys do the same thing. Change this back to 1. Change these to 1. Oh, that's one heck of a... Oh, there we go. I'm like, where are the dots? All right, so here's mine. Residual repairs. Okay, if I plot these out, 2, 3, 4, 5, 6, I plot out the points. What do I get? I actually get my analysis and the cost of repairs. Okay, so once again, it's a strong positive correlation because, and don't worry about the R squared, everybody, but the R value is 0.904. Okay, so that's a very strong, because remember, it's the closer to 1 it is, the better it off. And then if I were to do my equation would be y equals m, which was 216.8x, and then it's plus 770.6. So if I actually wanted to go in here and find out in the year, if I wanted to find out 8 years from the time from 2010, I could plug 8 in for the value of x, and it would give me the estimated cost of what I need to start saving up for that year. Okay, same here. What I want you guys to do is please graph and analyze the residual plot for the following data comparing graduation rates and unemployment rate. All right, on this one, guys, one thing I want to make sure you guys understand is that, let me go home so I can find it. When you plot these out, usually when an aspect like this comes up, when you're looking at this data, which one of these you may be asking is the independent variable, which one is the x, and which one is the y. Most likely when you see these graphs, the top number is going to be the x value. Most of the time we put time. Sometimes it may not be the case. In this case, it doesn't. I don't think it really matters because this is what we're looking for when we do it. Okay. Here is so I plotted them out. It gave me a line of regression. Now, what's interesting about this graph, okay, and I have it condensed down into a smaller window, is what is my line of regression? Well, it's actually 0.2951. Okay, that is my correlation coefficient. Is that a strong correlation? Remember, if it's the closer it is to 0 would be what? A bad correlation. Ladies and gentlemen, this is not a very good correlation. Okay, this is not very strong. Actually, if I look at this graph, what I notice a little bit here is looks like there's like a little bell right here. And the problem is because of the spacing issues away from the line of fit, this correlation is not a very good fit. Okay, so this is, we could draw an equation right now. So my equation would be is what? It's 0.44 or 45. So my equation would be y equals 0.045 m, and then m, and then it's plus 1.46. But the problem is that the correlation of this is not very strong. Okay, so this is what we would call a it does not, the regression line does not fit the data well. Okay, that's what you're looking for. You're looking to see if you have any type of line of fit regression. If you guys were in the medical field or any type of statistical analysis, you could plug this stuff into a desmos and you say, okay, is this a good line of fit? Does everything seem to be on task? And you'd be able to say yes or no. All right, two other things. Use the interpolation and extrapolation. Okay, so what we're going to do is we're going to use this data to extrapolate more data for further on down the road. So for example, we're going to enter this in, and then we're going to estimate how many points the 15th ranked player earned. So we've been looking, first off, we looked for the line of fit. We found it. We found the line of regression, which is the R equals. Now, ladies and gentlemen, we're going to transform this into an actual interpolation to kind of give us an estimation. All right, so if you guys look, go ahead and open it up, get on Desmos, and I'll do it at the same time, but you guys enter all these coordinates in. So this is going to be your X value, and this is your Y value right here. Okay, X and Y. Please make sure you enter in all 10 data points. All right. Go ahead and go. If you want to watch me do it, you can, but you guys should do it too. Key, by the way, how I'm deleting this so fast is if you just highlight it like this and you hit delete, it'll actually delete all the points for you. Okay, that's pretty cool. All right, so ladies and gentlemen, hopefully you guys are done. If you're not, go ahead and enter it in, okay, just so you know how to do it. Now what we have here is let's find out our correlation, okay? Is this a positive or a negative correlation? Well, this is actually a very strong negative correlation. Okay, it has a strong negative correlation. Our first one. All right, it's close to what number? -1. So that's what we're looking for. So we know it's going to be a strong correlation. Now, one cool thing, I believe this might work, it may not, is now it's going to ask us to estimate how many points the 15th ranked bowler would earn. So what you can do, is we talked about before, now that you have your line of fit, you can drag along the line here. We get to number 15. Come on. The estimated points would be 83.1. 83.1 would be 83 points. So 15th place equals 83 points. Okay, that's how many they get. All right, so what I want you guys to do is, hopefully you saw how I did that. Enter the information in the table. And then once you get the table, you can actually click on the line, so that way you guys know. So what I want you guys to do now, please, is to enter this information in your table. Okay, enter it in the desmos, and then just click along the line of fit that's automatically going to be created because of everything you've put in here. Okay, please make sure today on your notes that you guys put the Y1, the little approximation MX with the little 1, and that you go back and learn how to do this. Okay, I cannot stress enough how this will make your life so much easier. Okay, even if you struggle with all these concepts. So you guys get started on it, and I'll do my own here. And then I'll finish before you guys, but at least you guys will be able to do it as well. So go ahead and pause the video at this point, enter in the information, and then come back to me and hit the play button, and I'll show you where I'm at too. Oh, I made a mistake. Oh, there's two 111s. Alright, sweet. I even caught my own mistake. Make sure you guys don't mess up like I did. Alright, so let's go home, and then let me zoom out on this bad boy and see where these points are, and there they all are. Alright, so here are my points. So now what we're looking for, ladies and gentlemen, is we have our line of regression. Okay, if you guys look, it's a negative, a strong negative correlation because R equals negative 0.90922. I'd like to be able to tell you exactly how they got the correlation, but at this point, that doesn't really matter. Just know that you can use a calculator to get to that. Okay, the line of regression, the correlation coefficient, basically the correlation coefficient is this number right here. It's a strong negative correlation because it's close to -1. You can kind of see what I was talking about, how the dots are all along the line. They're like zoomed out this far, they're almost touching every single one, so it's got a very strong negative correlation. So now what you can do is we want to know at 90 degrees, where are we at? So if I go up here to 90 degrees, oh, I need to make the graph a little bigger. If I go up here to 90, my temperature is going to be, or not temperature, when the temperature is at 90 degrees, my attendance is, if I can get it to stop, 439 people, 0.4, so it'd be 439. Okay, so this one here is 439, and then this last one at 115. So if it's 115 degrees out, ooh, that's hot. It's like Arizona weather. 115 degrees, you expect to have around 144. So it's 143.98, but since it's rounded up, it'd be 144. So that's how many people are at the community pool for each of the following temperatures. So I believe, ladies and gentlemen, that is it for this lesson. Very Desmos heavy related. Learn how to use this table functionality. On your guys' homework tonight, okay? Make sure you use Desmos And to plug in this information, plug in your tables and use the data up here. Okay, remember how to do the y1, the approximation mx1 plus b. Know that the r value right here, okay, is your correlation coefficient. The stronger it is to 1 is a positive correlation. If it's the closer it is to -1, it is a strong negative correlation. And we're looking at anything above a 0.5, okay? Anything below a 0.5 usually means you have a weak correlation. And then remember your parameters here. This is your m, that's your slope, okay? There's your formula. So in this example here, my formula would be y equals -11.82 x plus 1503. Any questions on that, ladies and gentlemen? Use Desmos, please. I want you guys to all ace this test, and I want you guys to be able to, like we did on the midterm, be able to use Desmos to answer almost every single question that you can, and to blow every test, including the AC Merit, out of the water. You guys have a fantastic night, and I look forward to seeing you in class.